Hi everyone, in this video I'll be reviewing the workbook exercise 14.5 as well as a few more pages after that. So let's get started. Right, so in this question on question 1, right, question first asks about how to define pressure. Now I think that most of us in the class did quite well on this, so I will not spend too much on that. But I just want to highlight a bit about what does pressure actually depends on. In this question, they're actually trying to get you to think about the formula that pressure is being related to force and area. So in this case, the two factors are actually the force as well as the area of which the force is being applied over. Now the units for pressure, now this part is where can be a bit of confusion, but not to worry too much, but just that for us, right, take note that pressure is either measured in terms of Newton per square meter, or which is also equivalent to what I call Pascal, right? But of course in this example, right, they're actually trying to get us to think about Newtons per square centimeters. It's possible to express in this manner, but it really depends on the question, right? So it's either in this format, or you can express it in terms of Newtons per square meter, also known as what you call Pascal, right? So the units that you give over here can be either of these. And based on your answers, right, if you wrote about Newtons per square meter, you're supposed to write this unit, and the second unit will be called the Pascal, right? But if you wrote Pascal over here, you should write this unit with a capital P, take note, and this can also be known as the SI unit. So I think it's either of the answers are acceptable. Just want to highlight a few things, which is that whenever you're writing a unit, please take note of whether it should be capital letter or small letter, and it makes a lot of difference, right? So it's not just about us getting you to start with a capital letter or small letter, but you must always know which one is represented by the capital letter. Now let's go on to question 2. Now in question 2, right, there's two wheelbarrows, right? So there's wheelbarrow B and there's also wheelbarrow A. Now wheelbarrow B is rather obvious that it uses a bigger wheel, right? A bigger wheel would definitely offer a greater surface area. So the question that's being asked in the first part is which one will be more suitable when the ground is very soft. Now we know that if ground is very soft, it tends to sink in easier if the pressure is greater. So in this case, imagine that both wheelbarrows have the same amount of sand on it, right? You will want to have one that is has a wider wheel, or one with a greater surface area, and so that the pressure will in turn be much lower, so that the wheelbarrow is less likely to sink into the ground because the ground is very soft. Okay, so in part B, they also ask about the contact area of the two wheelbarrows, but this time they mentioned that the wheelbarrow in A, for A, is actually 1/4 that of the one in B. Okay, I know a lot of you mentioned about how the pressure in A is going to be greater than pressure in B, or it's going to be more than that in B. Okay, however, this will not be approved, this will be rejected. Reason being, the question did point out to us what is the difference in terms of surface area. So for us, right, it's important for us to know what is the differences and to highlight it as we explain about the differences. Okay, so don't just leave it as is being greater than or smaller than, but highlight how many times more. Is it greater? How many times more? Is it smaller? Okay, so I think this is the main thing that I want to talk about for this entire page. Now moving on to the next page. Now the next page, right, you're asked to construct certain explanation for why exactly certain phenomena is being observed. Now I just want to highlight a few misconceptions that I noticed in your answers, right? And this is quite important to make sure that all of us are on the right page. So we know that the formula of pressure is equivalent to force over area. So we need to be very mindful that whenever we are describing about changes in area, force actually doesn't change. The one that changes is pressure. So what do I mean by that? If you look at the equation itself, and I'm saying that, for example, let's say that pressure is equivalent to 1000 Newton over a certain unknown area. Okay, if you were to change this area, right, the force will still be remaining as 1000 Newton. It's not going to change because it's a constant value. So let's say that the box is heavy, so it's going to be 1000 Newton. Now the area can change, and when the area increases, we know that it's a pressure that decreases. So a lot of times I see in most of your answers is a lot of you tend to say that, oh, for this first example of the box, right, when the string has a small contact area, the box exerts a greater force. Now this is actually conceptually wrong, because the box's force is not affected by what is the contact area of the string. So the string can have a small contact area, it doesn't affect whether the box will exert a greater force or not. So in this case, you shouldn't be talking about the box exerting a greater force, instead you should be linking this to the fact that since pressure is equivalent to force over area, this will result in a greater pressure. Okay, so it's important to take note that when we are trying to explain about how area can affect pressure, we should not bring in the concept of force, because it will tend to confuse us, and it will come across as a form of misconception, which is technically a wrong answer. Okay, so although for some of you, right, I just marked based on your contact area as well as the pressure points, right? If you mention about force being increased or greater force being present, that's actually wrong, and you're not supposed to get the marks in this case. So over here, these are the answers. I think the main thing to take note of is here, whenever you're talking about surface area of contact, you can link it to pressure, right? There's no need to talk about force. Okay. For part B, likewise, there's a greater surface area, so this will be less painful because pressure is being affected. Okay. And for part C, we have a linking between small area to high pressure, and this allows the nail to work better to be able to pierce through the wall more easily. On to part 4, right? Part 4 is on the concept of pressure and skiing. Now, I think some of us might be a bit confused as to what 4A is trying to ask. 4 is actually trying to ask us what exactly is the calculation to find out what's the pressure that's being exerted by the skier when he were to not be wearing his skis. Okay, so if he's not wearing his ski, we're actually focusing on the area of the shoes. That means if he's standing on the snow itself. How are you going to convert the value? Now you notice that over here, the area for shoes is actually written in 400 centimeters squared, right? 400 square centimeters. So there's a need to convert it into what we are more familiar with, which is square meters. But take note that this conversion from centimeter square to meter square is actually not just divided by 100, which a lot of us are doing that. Okay, to divide by 100, yes, you can convert from cm to meters by divided by 100. But when it comes to square centimeters to square meters, right, you can no longer divide by 100 because of the square that's being seen over here, right? It's no longer just about dividing by 100, but instead you must divide it by 10,000. Okay, so how did I arrive at 10,000? Basically, is due to the fact that is to divide by 100 and then divide by another 100 because of the square. Okay, so to convert it, it will mean that if I were to convert all the centimeter square to meter square, I'll divide by 10,000, right? And this should give me 0.04 square meters. Okay, for the second one, if I were to divide by 10,000, likewise over here, it should give me 0.25 square meters. Okay, so this is to help us with the calculation later on. Now, for this first part, we're supposed to calculate the pressure that's being exerted when he's not wearing his skis. So we are going to take the force, which is his weight, 800 newtons, divided by the area that is being shown regarding the shoes. Okay, taking 400 dividing by 10,000, that will give us a certain value of 0.04. Dividing the entire thing together, we'll end up with 20,000 Pascal. Or you can write it as 20,000 Newton per square meters. Now I know that some of you converted into kilopascal. That's perfectly fine also, right? But there's no need to do so in this question. Moving on to the next question. In the next question, they are asking you what will happen if he were to put on his skis. Now, of course, this time around we are looking at a different set of a different set of area. So in this case, because we are looking at the ski, right? So the area that we are interested in now is here. So by dividing it by 10,000, we'll end up with 0.25 square meters, which we are going to use in our calculation over here. And this will show you that the amount of pressure now is actually 3,200 Pascal or 3,200 Newtons per square meter. What would probably happen if he tried to walk on the ground without skis? Now, if he were to walk without skis, we know that the pressure is a lot greater, because there's a higher pressure that's being exerted on the snow. So most likely this person will sink into the snow. I think most of you are fine with this question, so I'll move on to the next part on question 5. In question 5, this is showing you a diagram of a hydroelectric dam, but what you should realize is that as you go deeper into the water, right, the dam actually gets thicker compared to at the top part of the dam, right? And this has to do with pressure. The lower you go in water, the greater the pressure, right? In fact, some of you even remember what I mentioned in lesson, that for every 10 meters, it actually increases by about 100,000 Pascal. So why is the dam thicker at its base? Is actually to make sure that it's able to withstand the force that's being exerted by this increase in pressure. Okay, and for the last question on 5B, thought it would be interesting to talk about what is this concept of explosion. Now, explosion means from inside it must move outside, so it's like exiting out, right? So if you think about it for a second, right, imagine there's a fish over here. For the fish to explode, right, there must be an outward exerting force. Okay, and if you were to read this question carefully, it tells you that when brought to the surface, it actually expands in size, right? So expansion in size tells us that the internal part should want to become bigger, right? And why is that the case? This is actually because within the fish and comparing to outside the fish, outside the fish there's actually a low pressure when it comes up to the surface, because the higher you come up from the water, the lower the pressure. But inside the fish, there's actually a much higher pressure based on whatever things has been accumulated inside. And as a result, when you have a high pressure inside and low pressure outside, what the substance inside will want to do is to exit out, moving towards low pressure. Okay, so in general, things like to move from high pressure to low pressure, much like wind. Okay, so in this case, it will cause the entire fish to become much bigger, it will blow up, and eventually it will just explode. So the concept of explosion is similar to when you look at a grenade, right? We know that a grenade, when you throw it, when you pluck out the pin, right, it can explode. Why does it explode? Because within it, there's a lot of high pressure that's being built up, right? But there's very low pressure outside. And as a result, this high pressure will accumulate enough energy, and eventually it will just move outwards, right? Then that's where there's an explosion. So that's the concept of explosion. There's also a concept called implosion, right? So if you're interested, you can go and read up about it. Moving on to the next question. Now this question we're talking about vacuum cleaner, right? Pretty interesting, and also some interesting answers from you guys. Okay, so this is how a vacuum cleaner, an example of a vacuum cleaner will work. Not all vacuum cleaner work in this manner. Okay, so I think what is interesting is that most of you know that the air pressure inside the vacuum cleaner will actually get lower. But of course, we can elaborate a bit more using this diagram to find out why. Now there's a fan over here, right? And the fan actually eventually causes a movement of air up in this direction. So what the fan is doing is actually to remove air inside the vacuum cleaner. And when it does that, it actually creates an environment of very low pressure. Now when there's low pressure, what it means is that outside the vacuum cleaner, the air will actually have a greater pressure, right? So the air pressure is greater outside the vacuum cleaner compared to inside. So we are looking at a high pressure outside and an environment of low pressure that's inside. So as what I mentioned just now, air or rather substances tend to move from high pressure to low pressure, and what happens is that this generates a need for the substances to move in this particular manner, and that's why there's a suction force. So that's why all the dust will be sucked into the vacuum cleaner. So there's a pushing of the dust into the vacuum cleaner, or there's a suction force that's being generated. So that's how actually a vacuum cleaner works, by creating a difference in pressure and causing substances to move in this direction. So what exactly is the term vacuum, right? Vacuum actually refers to a space without any form of metal, right? So there's actually nothing, right? So it's emptiness, okay? So that's the idea of vacuum. To have a vacuum, right, it means that there must be zero air. It's not a space with very little air, right? It's also not a space with very little pressure. It should be a space with zero pressure. Okay, so it's important to take note that vacuum means it's really nothing. Okay, so there should be no pressure at all. So I think some of you also misread the question. You thought that when they ask what is a vacuum, you thought they are meaning what is a vacuum cleaner, right? But that's not what the question is trying to say. Okay, they're really looking at the term vacuum. So why is the name vacuum cleaner not that accurate? Because if you think about it for a second, a vacuum cleaner, right, is supposed to clean up vacuum, right? But it doesn't clean vacuum. In fact, it cleans the dust around it. But more importantly, it's also important to take note that a vacuum cleaner is unable to generate vacuum, right? Because vacuum means that there must be nothing. But we already established at the start that it removes most of the air inside, but not everything, because it still creates a low pressure. That means there's still some air inside. So another way to look at this question is to take note that a vacuum cleaner is unable to generate a vacuum within itself. Okay? It generates something close enough to be of low pressure, but not able to achieve the vacuum state. Okay, and that's all for this particular video from page 70 to 73.